Now I'm going to move on to the last example. That's going to be a bigger problem that we need to solve when we combine everything together, where we need to find homogeneous solutions to the homogeneous equations, then find a particular solution for the non-homogeneous equation using the method of undetermined coefficients. Then we're going to write down the general solutions and use the initial conditions to find a particular solution for the initial value problem. So again, I want to make sure that you follow with the naming convention here. The particular solutions that we mentioned here in part B is the particular solution for the non-homogeneous equations. And the particular solution mentioned in part D is for the initial value problem, where you find the exact value of C1 and C2 for the general solution. Okay. So let's start with that. Let's consider the homogeneous equation of this differential equation. So the differential equation is y double prime minus y prime minus 3y equal to 3t times e to the 2t. So the homogeneous equation is y double prime minus 2y prime minus 3y equal to 0. Then the characteristic equations is going to be r squared minus 2r minus 3 equal to 0. You can factor this quadratic equation to get r minus 3 times r plus 1 equal to 0. So there are two distinct roots, right? So r equal to 3 and r equal to negative 1. So the homogeneous solution is you have y sub h is equal to c1 times e to the 3t plus c2 times e to the negative t. Next, you're going to find the particular solutions. You have to give the trial solutions, find the first derivative, second derivative, and substitute into the non-homogeneous differential equations to find the undetermined coefficients. Now, the forcing term is t times e to the 2t. It does not mimic the homogeneous solutions at all. So the trial solution in this case should be a linear function multiplied with an exponential function. So the linear function because you have t, and the exponential function because e to the 2t. So the trial solution is you have y sub p equal to a times t plus b times e to the 2t. Then find the first derivative. So from here you get a times e to the 2t plus at plus b times 2 times e to the 2t. Now you simplify this result by taking e to the 2t as a common factor, and you get a plus 2at plus 2b times e to the 2t. Or you can write a 2 times at plus a plus 2b times e to the 2t. And then for the second derivative, you get yp double prime is going to be 2a times e to the 2t plus 2at plus a plus 2b times 2 times e to the 2t. And again, you take e to the 2t as a common factor. You're left with 2a plus 4at plus 2a plus 4b times e to the 2t, or you have 4at plus 4a plus 4b times e to the 2t. Now you're going to substitute this y double prime, yp double prime, yb prime, and yp into differential equations. So substitute yb double prime, yp prime, and yp into the non-homogeneous differential equations. We got that. So y double prime minus 2y prime minus 3y equal to 3t times e to the 2t. So y double prime is 4at plus 4a plus 4b times e to the 2t. Minus 2y prime, that is minus 2 times 2at plus a plus 2b times e to the 2t, minus 3y, so minus 3 times at plus b times e to the 2t equal to the right hand side, which is 3t times e to the 2t. So every term in the equation has e to the 2t. Therefore, you can divide both sides for e to the 2t, and we're going to get 4at plus 4a plus 4b minus 4at minus 2a minus 4b minus 3at minus 3b equal to 3t. Now we're going to simplify the left hand side a little bit here. So you get 4at, negative 4at, so they cancel out. So you have 4a minus 2a, you get 2a. 4b minus 4b get cancel out. Minus 3at and then minus 3b. This is equal to 3t. Alright, so let me rewrite this a little bit more. So you have negative 3a times t plus 2a minus 3b equal to 3t. Now the next step is to match the coefficients on both sides of the equations. So you have the coefficient in front of t, which is negative 3a on the left hand side, and on the right hand side you have the coefficients of t, which is 3. So that's the first equation you're going to get. So match the coefficients. And you get negative 3a equal to 3. This implies that a is equal to negative 1. Now to find b, we're going to use the second coefficient here. You have 2a minus 3b by itself, it doesn't have any t attached to that. And so 2a minus 3b is going to be equal to 0. So 2a minus 3b equal to 0, but a is equal to negative 1. So we get 2 times negative 1 minus 3b equal to 0. This implies that b is equal to negative 2/3. You know the value of a, you know the value of b. You can write down the particular solution for the non-homogeneous differential equations. So the particular solutions is, you have y sub p equal to, so you go back to the form of y sub p, which is at plus b times e to the 2t, for a is equal to negative 1 and b is equal to negative 2/3. So the form of the particular solutions is negative t minus 2/3 times e to the 2t. Now you combine this particular solutions with the homogeneous solution, and you're going to get the general solutions. So the general solution is of the form y equal to y sub h, stand for the homogeneous solutions, plus y sub p, stand for the particular solutions. You got c1 times e to the 3t plus c2 times e to the negative t plus negative t minus 2/3 times e to the 2t. And that is the general solutions. Now when you are given the initial conditions, in this case y of 0 equal to 1 and y prime of 0 equal to 0, you can find the specific value for c1 and c2 and solve for the particular solutions of the initial value problem. So again, we're going to utilize the two initial conditions. So start with y of 0. So y of 0 is going to give you c1 times e to the 0 plus c2 times e to the 0 plus 0 minus 2/3 times e to the 0. And this gives me c1 plus c2 minus 2/3 equal to 1, or c1 plus c2 equal to 5/3. So that's one equation. Now the second equations that we need to solve for c1 and c2 coming from the second initial condition, y prime of 0 equal to 0. So from y, you get y prime to be 3 times c1 e to the 3t minus c2 times e to the negative t. And you have plus negative 1 times e to the 2t plus negative t minus 2/3 times 2 times e to the 2t. So these two terms right here coming from the derivative of this product. Okay, so simplifying the results a little bit, so we got 3 times c1 e to the 3t minus c2 times e to the negative t minus e to the 2t plus 2 times negative t minus 2/3 times e to the 2t. and apply the initial conditions. Y prime of 0 give you 3c1 e to the 0 minus c2 times e to the 0 minus e to the 0 plus 2 times 0 minus 2/3 times e to the 0, or 3c1 minus c2 minus 1 plus 2 times negative 2/3 equal to 0. This implies that 3c1 minus c2 going to be 7/3. Okay, so this is the second equations that we need. Now, from these two equations, you can find the solutions to C1 and C2. So we obtain the following system of equations. So you have C1 plus C2 equal to 5/3, and 3C1 minus C2 equal to 7/3. And if we do the calculations correctly, you can get C1 to be 1 and C2 to be 2/3. And then plug that back into the general solutions, you're going to get the particular solutions to the IVP as y equal to e to the 3t plus 2/3 times e to the negative t plus negative t minus 2/3. So this is a bigger problems that we have just solved. So in this problem, we have the initial value problem, and first of all, we solve for the solution of the non-homogeneous differential equations by first finding the homogeneous solutions corresponding to the homogeneous equations, then find the particular solutions based on the forcing term, which is the right-hand side of the differential equations. And then you combine homogeneous solutions and particular solutions to get the general solutions. And given the initial conditions, you can find the specific value for C1 and C2 to get the particular solutions of the initial value problem. One thing I want to note here is that when determining the value of C1 and C2 for the initial value problem, that is where you take into account the initial conditions, you must use the general solutions, right, which include both homogeneous solution and particular solutions, instead of just the homogeneous solution found in part A. So be careful with that. So let me write down that note here. When determining the value of C1 and C2, for the initial value problem, you must use the general solutions. Which include the homogeneous solutions and particular solutions. So be careful with that. All right, so that's it for me for this lecture. This is lecture 12. We focus on the undetermined coefficients method. This is a method to tackle a different class of differential equations, different from the last two lectures that we have done. So using undetermined coefficients allow us to find the particular solutions to a non-homogeneous differential equations. And when find the general solutions to the differential equation, remember you need to include both homogeneous solutions and particular solutions. All right, so that's it for me. Please let me know if you have any questions. Thank you.